Welcome. Right, so now we're going to be graphing with E. E is the natural base. Right, so it's an irrational number. E is called the natural base, right, because it's the base of all naturally growing organisms. The function f of x equals e to the x is called the natural exponential function. Since e is in between 2 and 3, the graph of y equals e to the x is between the graphs of y equals 2 to the x and y equals 3 to the x. Right, so the dark blue graph is y equals, or f of x equals 3 to the x. The light blue graph is f of x equals 2 to the x. Right, so f of x equals e to the x is growing faster than f of x equals 2 to the x because, well, e is larger than 2. And it's growing smaller than f of x equals 3 to the x because, well, e is smaller than 3. All right. So when they intersect the point 0, 1, because whether it's 2, 3, or e, any of those raised to the 0 power, that's 1. But 3 to the first power is going to be 3. Right? So it's larger than e to the first power, which is e, or approximately 2.718, and which is larger than 2 to the first power, which is just 2. All right, so basic idea. Our parent graph there, e to the x. We're going to use that parent graph to graph some transformations. So we're not going to spend a whole lot of time on graphing e to the x without transformations. Matter of fact, we're going to spend one slide talking about it. And that's because it's really no different than graphing any of our other exponential growth and decay. And the transformations are exactly the same. All right, so I have this in your notes for you, and it is a wonderful list of the steps. All right, my own words. Graphing exponential growth and decay, and my handwriting looks so nice, I have to say. Graphing exponential growth and decay, E is a base. So you're going to graph your base function, which is everything except h, what's added to the exponent, and k was added to the function. So for instance, if we have y equals 2 times e to the x plus 4 minus 5, your base function is going to be y equals 2 times e to the x. You'll translate the function horizontally and vertically. If the function translates vertically, make sure you graph the new horizontal asymptote. So for instance, if the graph was y equals 2 times e to the x plus 4 minus 5, we would take our base graph and shift it 4 to the left and 5 units down. There would be a new horizontal asymptote, and that new horizontal asymptote would be y equals -5. And by the way, it's going to change our range because the domain and range for e to the x is the same as all of our exponential functions. Right? Domain of all real numbers, and a range of 0 to infinity unless we reflect it or translate it up and down. So for decay, simplify the negative exponent to graph the base function. All right, so if we have y equals 2e to the negative x, make that y equals 2 divided by e to the x. And now you know the steps. Let's get started. On all of the graphs, I put the same table of values, which is the values for e to the x rounded. All right, so in other words, and you can write this in your notes. Actually, I think I'm going to write in yellow. I think it'll show up nice on the green there. All right, so this would be e to the -2, which is approximately 0.135. E to the -1 is approximately 0.368, because this would be the same, by the way, as 1 divided by e squared. And this would be the same as 1 divided by e. E to the 0, of course, is 1. E to the first is 2.718 approximately, and then e squared is 7.389. So that's what those values mean. All right, we're just plugging them in for the exponent there. Whenever possible, I even gave you this base graph already graphed so that you wouldn't have to keep graphing it. But if we have something else multiplied to e, then our base graph would change. So then I couldn't do that. All right, so we have our base graph already done. Oh, look at that, we're done with that part. So we graphed f of x equals e to the x, that's our base graph. Now we just need to translate it. Our graph is going to move, since we have x plus 2, it's going to move 2 units left. Because we didn't move up and down, the horizontal asymptote is still y equals 0. And matter of fact, our domain is going to be all real numbers, and our range is going to be 0 to infinity because we didn't translate up or down. And so now what we got to do is just graph our function here by moving our points to the right, to the left, to the left, to the left, to the left. Here we go. To the left, to the left, 2 to the left, and 1, 2 to the left. All right, so you're going to be approximating because you're going to have a bunch of decimals, but it's not that hard to go 2 to the left. And there we go. There's our graph, and we're done. Let's graph another one. So we spent a lot of time learning how to, graph our exponential growth and decay with transformations. But now we got all the rules down. This isn't going to take long for us at all. All right, so now we have 1/2 e to the x minus 5. So now I didn't give you a base graph because it's not e to the x anymore. Our base graph is y equals 1/2 e to the x. All right, so a little bit different, but it's not that difficult. All we have to do is take e to the x and divide by 2. Now, by the way, you can easily plug this into a calculator, all right? And I will be happy to show that to you when we're working on your weekly work. And I better make sure I have a calculator handy. Sometimes I'll need it. On this one, I think I'll be okay for most of them anyhow. All right, so I'm going to take all of those and divide by 2. All right, so that means on the first one there, we have 0.135, and we're going to divide that by 2, and that is 0.006. Oops, now I can't write in yellow anymore. There we go. You won't be able to see it on the white. 0.0675. So it's like half of 13.5 with like decimal points. 0.368 divided by 2 is going to be 0.184. A whopping 1/2. I have to write that one again. I don't know why I bothered to. 2.718 divided by 2 is going to be 1, and then 3, 5, 9. 1.359, right? Sometimes I don't know what it is about decimals. If it was 2,718, I wouldn't have any issues. But somehow with decimals, I'm always like, oh, did I remember to divide that one? I don't know. 2.7, I'm just going to double check. Yeah, it's correct. And then this one here would be 3, and then 0.6, and then 9, and then 4, 5. There we go. Now, obviously, we're not going to be perfect in graphing our decimals here, right? You're going to be able to graph 3.6945, right, to the exact decimal. You're just going to approximate. All right, so 0.0675. Well, that's really, really small. First of all, let's graph our horizontal asymptote. That's just really, really small. So maybe we leave off -2, right? That's pretty small, right? That's about a 20th, all right? That's really small. But let's graph the next one, 0.184, all right? So, well, if it was 0.2, that'd be a 1/5. So it's a smidge less than, me not graphing yellow, it's a smidge less than a 1/5, right? So, right there would be good. All right, then 1/2, we got that one. And then for 1, it'd be 1.359, so about 1 1/3. And then 3.6745, kind of close to 3 3/4, right, roughly speaking. All right, so here's our base graph, right, a slower growth, right, than the last one because it's a half of e to the x. And now we just need to translate 5 units down. All right, so new horizontal asymptote at -5. So let's write that in, y equals -5. And then we're just going to move all of the points down 5. And that's all there is to it. So that, of course, is going to be right there. And then 1, 2, 3, 4, 5. And then I sometimes look and see, okay, so it's 1 1/3, 1 1/3. I think that one's easier than counting when I've got decimals. So 3 3/4, 1, 2, 3 3/4. There we go. So there's our points, and they're all moved 5 down. Domain for all exponentials, growth or decay, all real numbers, -infinity to infinity. We shifted it down 5, so -5 to infinity is the range, and we're done. Another one done. Let's graph again. And so the first two have been growth. This one is decay. Right, so now we have a decay. And, well, the D is not where it belongs. Now, let's put it there, move it to where it belongs. All right, so now we're going to rewrite that as y equals 3 divided by e to the x. Remember that exponent only applies to what's directly in front of it, so that negative only applies to the e. All right, so just as a reminder, and this should all be in your notes, if x is negative, change e to the reciprocal. If that's not in your notes, then add it, but I think it is. All right, so now I couldn't give you the base graph because it's not e to the x. We're graphing 3 divided by e to the x, but we can use these values, which is why I have them up here, and feel free to use this little table of values if you don't want to have to plug in e to the x into your calculator, right? Because you'll get the same thing. All right, so we're dividing 3 by all these values. All right, and so that's going to give us, so now I really need to calculate. 3 divided by 0.135. All right, 3 divided by 0.135. I'm trying to hold a microphone, a pen, and a calculator all at the same time. And that is, so you're dividing something by a really small number, it's going to get really big, right? Because, so if you have 3, and, wow, you're dividing it, so 0.135, that's less than a fifth. That's less than a sixth, right? So how many sixes are you going to make if you have 3? Well, if it was a 6, you'd make 18. But 0.135 is even smaller because you're going to make 22.22. And that's a value that is just not going to fit on this graph. All right, so 3 divided by 0.365, which is 3 divided by e to the negative x. Maybe I should actually write that in there on yours. So, well, this would be 3 divided by e to the -2. Maybe I should do that on this one. 3 divided by e to the -1. 3 divided by e to the 0. 3 divided by e to the first. And 3 divided by e squared. Look how I use those values that were there. All right, so 3 divided by 0.368. And that's going to give us still a really big number. Did I get the other one right in the first place? Let me just divide that again. So 3 divided by 0.135. Yeah, that's 22. And then 3 divided by 0.368 is, okay, there we go. I must have had my something, and I had a decimal in there. That is 8.15. I got 20 the first time, so obviously I didn't divide 3 by the right amount, right? Because we should be 1 eth each time, because e's our base. All right, and so now I think I can do 3 divided by 1. no problem. And then 3 divided by 2.178 is going to give us 1.374. And we need to make sure we have at least one value below 1. And so that would be 3 divided by e squared. So that's 3 divided by 7.389. And that is 0.4. Oops, I just hit the calculator. But I saw it was 0.406. Approximately 0.41. Right? So 4/10, 2/5. All right, so we're completely skipping that first value. But -1 was 8.15. So notice decay, we're headed back to the asymptote. And speaking of asymptotes, let's graph that in there. All right, now let's continue. All right, so now we have e to the 0. That's going to be 3, because it's actually 3 divided by e to the 0. Right? And your starting value is always going to be your y-intercept. And your starting value here is 3. And then for 1, we have 1.374, so a little bit more than a third. And then for 2, we have about 2/5 right there. All right, so here is our base graph. And we need to graph our function that we have shown there. We need to translate that base graph 4 units up. That gives us a new horizontal asymptote of y equals 4. Excuse me. And then we're just going to take our points and move them 4. We'll even move this one 4. So 1, 2, 3, well, like up here. All right, and then this one's an easy one to move. 1, 2, 3, 4. Goes from 3 to 7. And then here, so I'm 1 and a third, so 1 and a third. And then like 2/5 from the asymptote. There we go. All right, so, whoa. Well, it did not want to write up there. Let's try it again. Let's go backwards. There we go. All right, and domain and range. And I think it looks right for you, but you know, my range is off my board here. All real numbers for the domain. Since it's shifted up 4, the range is 4 to infinity. And another graph done. All right, so we had 2 growths, we had a decay. What will be next? Will it be growth? Will it be decay? It will be, and waiting, decay. All right, so here we gotta be careful. All right, I didn't automatically write it in because we need to factor out the coefficient on the exponent there. All right, otherwise we'll be making a mistake. All right, so we need to factor out the coefficient, and we'll always have to do that if it's not factored out on x. All right, very important. Put an exclamation point. All right, well, it doesn't want to write there because I have a recording box there that you can't see. How about now? There we go. All right, so we'll factor out, but easy factor. So y equals e to the -1. If you divide both of those by -1, it's x plus 5. Otherwise, we would have gone the wrong direction. Right? We saw that when we had a negative on the coefficient for the radicals. Right? Anytime you have a coefficient on x, you got to factor it out all the time. Right? So now I couldn't give you a base graph because our function is right there. Our base graph, let's write base graph. That's y equals e to the -x, right? -x. All right, so that's just going to be, so we're going to have 1 divided by e to the -2. All right, so that would be 1 divided by, and that would be the same for all of these. So I'm just going to write that in. I think I'll do that one first. 1. And then 1 divided by e to the first. and 1 divided by e squared. What do you think 1 divided by 0.135 is going to be? I'll tell you that it's a number that should be in that table there. All right, let's find out. 1 divided by 0.135. Why, it's 7.4 because I rounded, all right, but 7.389. And I can't write in blue or in yellow. So that's going to be 0.7389. All right, and guess what the next one's going to be? That's going to be 2.718. And that one won't change. And this one's going to be 0.368. Oh, I forgot to write in the divided by 1, the 1 divided by on these ones. And the next one is going to be 0.135. And if you think about it, let's just say it was 3, right? So if I had 3 to the negative 2, that would be 1/9, right? Because I'd have 1 over 3 squared. But 3 squared is going to be 9, right? So, but now if I had 1/3 to the 1/3 to the negative 2, that one would be 9, and the 1/3 to the square, that would be 1/9. All right, right? Because it's the same. It's just a reciprocal. All right, so e to the negative 2 is the same as 1 over e squared. All right, so we have our values, and it's almost the same as the base graph. It's just reflected over the y-axis because it's now decay. All right, so this one was decay as well. All right, so let's first of all graph the horizontal asymptote. All right, and then we'll graph our function. All right, so we have negative 2 is 7.3, so 7 1/3, oops. Right, well, if I make my dot really big, it'll be in the right spot. It should be 7 1/3. That looks like 7 1/2. All right, and then for negative 1, it'll be 2.7, and that one's 1, and then about 1/3, and then like a little bit more than 1/10, really small. All right, and we won't cross the asymptote. Our function is shifted 5 units left because we remembered to factor out the negative 1. Otherwise, we would have gone the wrong way. Horizontal asymptote is y equals 0 because we didn't shift up or down. We just shifted to the right. Excuse me, to the left. All right, and so now let's move our function to the left 5. So 1, 2, 3, 4, 5. Oops. Well, that point didn't go where it was supposed to, but I'll just move it up a little bit. And then 1, 2, 3, 4, 5. So if you can count 5, you can do it. All right, so this is just going to move right over here, negative 5, and then, of course, negative 4 and negative 3. And we're not going to cross the horizontal asymptote, and there's our function just shifted 5 to the left. So the domain, of course, is all real numbers. Oops, that wasn't supposed to pop up. It's still getting closer and closer. There's a limit to how much closer I can draw. Let me fix the bottom of my graph because I got this weird little glip going up. There we go. All right, and then the range, 0 to infinity, because we didn't shift up or down and we're not reflected. All right, another graph done. I don't think there's too many more graphs. This one's going to be, I think, under 30 minutes, or pretty darn close to 30 minutes. All right, so here we have another decay one, and we have to remember to factor out the negative. All right, so this one is going to be, so it's decay, and we want to, factor out negative 1 on the x. All right, so this function here, I'll move this graph down a little bit because that's our base graph. All right, so this is going to be y equals e, and we're going to factor out the negative. That'll make it x minus 1 minus 2. We're going to graph y equals e to the negative x. All right, and it was the same values we had a slide ago. So they're just going to switch, right? This one's going to be, so instead of this, it's going to be 7.389. This is just a reciprocal. This one's going to be 2.718. That won't change. This one is 0.368. This one is 0.135. There we go. Ta-da! Let's graph our horizontal asymptote. There it is. Ta-da! And now let's graph our base graph. All right, so we have same one as before. Oops. There we go. My point started a little too high. And then 2.7, and then 1, and then like a third, and then like a tenth. Actually, more like maybe an eighth. All right, there's our graph. All right, and all right, so which way are we shifting? All right, so now we've got an x minus 1, so translate 1 unit to the right and 2 units down. We have a new horizontal asymptote. There's a new horizontal asymptote in town. It's y equals negative 2. So let's graph that new horizontal asymptote. There we go. And let's graph our function, and then we'll put in the domain and range. All right, so 1 to the right, and then 2 down. So 1 to the right, and 1, 2, right there. 1 to the right, and 1, 2. And 1 to the right, and 1, 2. And then, well, it's easier for me to count up a little bit. So a third, and like an eighth. And there we go. So our graph has now been shifted. 1 to the right and 2 down. The domain, as always, for every single exponential is all real numbers. And the range is negative 2 to infinity because we shifted the function down 2. I thought it was going to be under 30 minutes. I don't know. Let's see. But how many more we have? And we're waiting for our next graph. Oh, there is no next graph. That's the next unit. So, we were under 30 minutes as promised. Thanks for watching this podcast, and I'll see you on the next podcast. Bye for now.